when you are given a side, and an angle that is not between those two sides, in other words, side angle, it's called the ambiguous case for the law of sines, because you don't know if you have 0 triangles or exactly 1 triangle or 2 triangles. So here's what I recommend. When you draw your picture, start with the angle. Always put the angle on the left hand side. Alright, so the angle is 62 degrees, and that's angle A. Okay, now they give you 2 sides. So they give you side A is 13. Now this dotted line is side A. Okay, now I'm putting it as a dotted line because it's unknown. We don't know if it will actually form a triangle, or we don't know. It could be a vertical line, or it could bend inward like this. Alright, that's why it can form 2 triangles or 1 triangle, or it'll form no triangles if it doesn't reach. So I put this as a dotted line so you can imagine it as a swinging rope. It's a unknown variable. Anyway, so we have angle A. Side A is always across from angle A. Now, the other side that we have is side B. Let me erase this. I put side A here, but we know that side A is 13, so I should go ahead and put 13 right here. Now, so the other side is length 9. Always put that on the left. Okay, now that is side B, so that means angle B must be here. Side B is always across from angle B. That means angle C must be right here, and this is side C. Okay? Now, here's the thing. Let's take a moment and find the height of this triangle that I'm drawing here in green. Alright, this is the height. Okay, and the height is always going to be r sine theta. Okay, now when I say r sine theta, r is what I'm calling this side over here. Alright, so the height is going to be 9 sine 62. Okay, so what's the height? Put that in your calculator. Alright, it's taking a while. 9 sine 62. You know what? I'm realizing that we're in radian mode. I need to be in degree mode. Okay, please make sure your calculator is in degree mode. Alright, so it's 7.9. Okay, so look, the height is 7.9. Keep that in mind. So think of this unknown side as a rope. So the height is 7.9. So it takes 7.9, it takes a length of 7.9 to reach the ground. Is this rope long enough to reach the ground? Yes, it is. Okay, it's definitely long enough to reach the ground. The rope is length 13, so it will reach. So we will definitely have at least one triangle. So we can throw out, we can always determine it, so it's never going to be impossible. So we can throw out 0 triangles. So now the only question is it going to be 1 triangle or 2 triangles? Okay, now the way that it could possibly be 2 triangles is if the rope could fit here in this blue position and also here in this purple position. Alright, if the rope will fit in both places, then that will make 2 different triangles. So the question is, will a 13 fit right here? And the answer is no, 13 will not fit. And that's because this side on the left is 9. If this side is 13, well, that's longer than 9, so it's going to stretch out. It's longer than 9, so there's no way it's going to fit underneath 9. All right, this has to be shorter than 9. If this were 8, then it would fit, but it's 13, so it breaks out. It's too long. So that means it won't fit on the inside. It'll only fit on the outside. So there cannot be 2 triangles. So that means there will only be 1 triangle. So the answer is B.